Hello, students, again. We are now going to try to look at the digital multimeter. So we'll refer to this as the DMM or the multimeter. And so I just want to bring that in. And if you guys use Multisim, you will see this here. And so I'm just going to pop this meter in and I'm going to connect this meter to this side. And as I connect that meter to that side, you will see that we can get some interesting information here. And so if I just run this, you'll see that we can pick up our voltage. And if you actually look at the voltage on this, you'll see that the actual voltage is going up and down. So what you want to do is you don't want to, if you have an oscillating voltage, you want to select this signal here. So this allows us to get, how can I say, the root mean squared voltage. So let me just double click on the function generator. And on the function generator, you'll see that we have 10 volts here, peak to peak. So that means we have, well, we actually have 10 volts peak. So that means we have 10 volts, and if I bring up my oscilloscope here, we actually have 10 volts from 0 to this point up here and from 0 to this point down here. So you'll see channel 1, it says 10 volts here. So that's going to be 10 volts per division. So this division is 10 volts and this division is 10 volts. That is what is meant on this function generator. Okay? Cool? And so you see that our multimeter is giving us a root mean squared voltage. So if it was oscillating, you would see that oscillation. But what you see is some voltage that's lower than the peak to peak. Okay? And there's a mathematical representation for that. But I want to bring in the iCircuit view, and so that's what I'll do here and try to compare these two. So you'll see we have our iCircuit here, and I can just stop this simulation. Let me see, stop that. And so you see that we have 1 hertz. If I double tap on this, we have a frequency here and we have an amplitude. It's saying an amplitude. The amplitude is the same thing as the voltage, the VP, and that's voltage peak. So I need to put this at 10. And so this should give us the same. And let me just double check on the frequency here. The frequency here is 1 hertz as well. So it's 1 hertz here. So if I open up this meter, both of these meters, you'll see how the meter on our, and I hadn't brought this, let me bring this back up. You'll see how the meter on our iCircuit is oscillating. I'm not quite sure yet how to make this root mean squared, but it's oscillating. And also, you see all of these selected, the I, the voltage, and the power. You'll notice that on Multisim, that all we have is the voltage. It's all we can really look at. Everything else would be a calculation. So let me pull this back up, and I'm just going to select voltage only. And you'll see the root mean squared here. Okay, so for voltage, we have our root mean squared here. You don't see it over here. It would be nice, and it probably is something that I'm missing. But you'll see voltage peak to peak. Again, that's from this 0 line to the peak. From this 0 line to this peak, that's 20 volts. But it's 10 volts from the center line up to the peak. So it's the same way. The frequency is, it should be 1 hertz, and it is 1 hertz. So, and here's our voltage, and I don't know what that AL, I'm just going to assume that that means average, but I don't think that that's what that means. I don't know what this one means. But any two ways, this is how we can relate what we have on the iPad to what we would have with an industry standard, and that is Multisim here. Okay?